This week we're going to be talking about product lifecycle management. You should be reading what chapter out of the textbook? Chapter 23 is what we're going to be covering. It's I think, a very good overview of what product lifecycle management is. It doesn't do much in terms of introducing you to the tools. And so today's lecture is going to focus mainly on kind of the overview part of it. Thursday's lecture will begin talking and kind of dealing directly with Team Center engineering. In lab this week, we will be doing introductions of teams. So you'll break up into your designated or assigned teams. You'll spend some time during the lab trying to reach out to your team members or have them reach out to you through Skype and through Google Docs and through a bunch of other tools that we'll introduce you to. And so the first part of lab is going to be kind of introductory, and it's going to be formative. You're going to be getting into your groups. You're going to be learning what car you're going to be modeling and working on. And then the second part of the lab is going to introduce you to Team Center engineering, the way it's configured here at BYU, and the way it's configured at other remote sites, with the exception of UBC, is that a client has been installed, and that client will basically link us back to the database, and the database is going to be saved or stored up in Canada on the British Columbia campus. And so on Thursday, we'll get kind of neck deep in talking about the specifics of Team Center engineering, what it does, how it works, how you should use it. You'll also be seeing that kind of discussion in lab. Okay? So for today, what we want to do is jump into this discussion of PLM. Before doing that, there's a whole bunch of terms that the author introduces, and we might as well make sure that we kind of know what these terms are and understand them. The first term, PLM, stands for Product Lifecycle Management. That's going to be the basis of this kind of discussion. PDM is Product Data Management. It's the precursor to PLM. Okay? Product Data Management goes back to when I was sitting in seats very similar to what you're sitting in. So it goes back to the beginning of time, beginning of CAD time, almost. So back in the 70s and 80s, they had a strategy for managing product data. And that's what the PDM systems of that era were all about. ERM and ERP are Enterprise Resource Management or Planning. Those tend to be kind of the Sept tools. They are the financial corporate management tools that sit above the engineering data. Okay? So they're another layer of tools for making sure that businesses are profitable and the products that they make can be sold at a good return. SCM is Supply Chain Management, and that's a bunch of software tools that allow you to reach out to your supply chain and interact with them. Okay? So generally those things have very secure data links that are highly encrypted, 254, 56-bit encryption. 256-bit encryption is pretty standard for doing supply chain exchange of data. The CRM, customer relations management, that's again, another suite of tools that allow you to kind of collect feedback from your customers. The General Motors, the Fords, the Boeings, the Caterpillars, the John Deeres of the world want to make sure that their customers return to them recommendations, improvements, problems, any kind of feedback on what the product is or isn't doing. The manufacturing engineering company wants to collect that back. We have two bill of materials that are commonly discussed, the E-BOM and the M-BOM. Engineering bill of materials, the manufacturing bill of materials, and they're not always equal. Generally, they're really close, but they may have slight variations and differences in them. Anytime we refer to a CAD system or CAE or CAM system, we're really talking about the engineering tools for making, designing, analyzing a given product. And then the bottom one is the DFX, which is design for, assembly for testing, for manufacturing, those types of things. And these acronyms are very prevalent and very they're heavily used in the literature that you should be reading or looking at as engineering students. So as we jump into product lifecycle management, the engineering landscape has changed drastically because of the way in which companies work has changed. The author cites three things. Operations occur in distributed facilities. So no longer do we have the Camaro being manufactured and designed in Detroit, okay? So it's happening in distributed facilities. Product design is no longer happening 8 to 5. Do you ever see an engineer working a swing shift or a graveyard shift? Not really. You see manufacturing doing that, but engineering typically has been an 8 to 5. Sure, they may tack on a few overtime hours, you know, in the week, but generally there's not a swing shift or an engineering swing shift or an engineering graveyard. Because we needed more hours in the day, companies decided, well, if I distribute my facilities around the world, there's no reason why I can't chase the sun, so to speak. Work on it 8 hours, pass it ahead, work on it 8 hours, pass it further ahead, work on it 8 hours, bring it back to its home state, and have 24 hours of work being done. So work is happening around the clock on products. Design responsibilities have been decentralized. In other words, the aesthetic design may be happening in Detroit, but the actual engineering design that has to follow that or be coupled to it is happening down in Australia. Early computer-aided engineering tools lacked the ability to easily exchange information and interoperate. So back in my day, okay, if you did something on CAD system X and a supplier was using CAD system Y, they generally had to recreate it. The early versions of data exchange, which we'll talk about in a couple of weeks, called IGES, were very poor implementations of data exchange. You could transfer data, it was highly unusable. Okay? And so they needed to have some kind of environment that allowed this material. If you're going to chase the sun, if you're going to distribute it, there had to be some kind of an environment developed wherein you could easily move and archive data. So PLM systems were basically an outgrowth of PDM systems. Okay? And it's a framework that's intended to manage all facets of a product life cycle, from its very early conceptual sketches all the way through and including the retirement, the recycling, the disposal of that product are intended to be captured inside of a PLM environment. So what does a PLM framework consist of? Well, first off, it consists of a database, and in today's terms, generally the database is an Oracle database. It doesn't have to be, but industry has kind of gone that direction just because of the stability of what Oracle provides.
Is Oracle just the type of the database, or what exactly is Oracle?
Okay, Oracle is it's a company that sells a database environment, okay? And their database environment is known to benchmark against all other databases and usually win benchmarking. So from the standpoint of this being a large data vault, you can think of it kind of as a file cabinet that you can just pour things into, and it organizes it into folders, it organizes it into drawers and locations that you can easily retrieve. They go with this Oracle environment. Now, prior to having a database environment to work in, what existed out there were files. Okay? And we save files off to our local drive. We save those a lot. We also save them off to our J drive, or we save them off to a thumb drive. Whenever you save a file off, that file is intended to kind of be open and closed by one person at a time, right? The thing that's nice about a database is when you put things into a database, hundreds, thousands of people can access and look at that data item at the exact same moment. It's not like when I have a file, nobody else can see it, or if they see it, it's a read-only version that they're able to see it, okay? Also inside of the framework, it's an operating system or an operating environment. You can think of it as an OS, okay? Just like Microsoft, just like Linux, it's an operating system, and that operating system gives you file structure, gives you a mail structure, routing systems, it provides security for you, provides version control, versioning. Okay? So all of those things are built inside of this operating system. It also allows you to kind of work with three different parts of the product design. So one area that you can work with is what we call the product definition. So the product definition could have a kind of a design envelope model. So think of this first model on the left as the design envelope that you're trying to build to or design to. This part would be saved into the database, into the Oracle database. Anybody in the company could look at this. It's not on your C drive. Another engineer comes along and says, we're going to do a topology optimization on this part. And so he grabs the part, takes it into another system called OptiStruct, loads it, constrains it, and says, show me the load pattern